Hello, everyone. So I want us to look at a very important definition or concept that is very foundational to the chain rule, and that is known as the composite function. It's a function of two or more functions where the input of the other function. Okay, so then it just means that if, for example, if I have two functions, then they are composition. Okay, they compose. So there's a way we kind of denote that this is a composite function. So the compose, I write that the compose function. So if I have f and g as my function, then the compose function will be written as this. Okay, so this is how we write it. Then what happens that their composition, what happens that the composition of such two functions, okay, the composition of such two functions f and g will be defined as this. Okay? Will now be defined as now. This is what becomes interesting. So what it just over here for us to find the composite of this, let me just write it well so that it becomes easy for you to. So let me use a different pencil over here. Use a different pencil so that you can relate it well. All right, over here, this is what we were going to do. We're going to assume that, or we're going to say that the G will now becomes the input for the F. Okay, so by doing so, we're going to have F as this. Okay, see how we do it. So if this is this, then what then becomes something as this? What if I give you this? What it means is that now F will now going to be the input for the G. Okay, in that case, you're going to have what? G. So I'm giving you different scenarios so that you appreciate the concept very well. It's, as I mentioned, it's also foundational to our main the day. So let's bear this in mind. I hope we are okay. So if I give you a problem as this to try it out, I just want us to have a feel of how we can use it. So suppose that you have f of x equal to, let's say, x to the power 3, and that of, let's say, g of x equal to 1 minus x. What then if I was to find something as this, and if I was to find fog and gulf, how do you find it? So for the first one, with fog, it just means that my G is the input for F. In which case I can write it as my G is what 1 minus X, right? Now over here, it just means that wherever I see X in big F, wherever I see x in F, I should just replace by 1 minus x, right? So we're going to have something as this, right? The B part we have gulf, and the gulf means that my F becomes the input for G. In that case, I'm going to have something as this. Now, what's my F? My F is defined as what? X to the power 3, which means that wherever I see x in G, I should just replace it by x to the power 3. And that should give us what? 1 minus x to the power 3. Good. So that is the way composite function is kind of worked out. So I want us to now look into what we call the chain rule. So we kind of look at the theorem. So the theorem is the chain rule. Now, what then becomes the derivative of the composite function, of this composite function? What then becomes the derivative of the composite function, which is fog? Now, what it means is that, so, looking at what we did earlier on, it just means that our G will become the input for F, right? So in which case, you're going to have something as this, okay? Good. Now, over here, what do we also apply the cover up, okay? So over here, I can decide first to cover, I can first decide to cover the G. So for the first instance, I can decide to cover the G. So if I cover the G, it means that I'm now going to, it's almost, when I say cover, it's almost as if you are just placing your thumb on G, which means that G does not exist, right? If you differentiate your F, if you have F prime, then remember you've covered your G. In your mind, it is there, but you have covered it. It's as if you are blind to G, but now you are not going to differentiate your F. When you differentiate your F, you're going to get what? F prime, okay? Then you bring your G of x. Then we multiply it by, now you covered your F and differentiate your G, which is just the input. Is that okay? Good. So let's take note. I believe it's simple, right? If you have any questions, please put it in the comment section. And as I said, if you found this content useful, please like, subscribe, and also kind of, share it with your colleagues so that they can understand the basis of calculus. See, the reason why I'm taking my time to do this is because I want you to be well grounded in mathematics. If you are well grounded, when we begin to take this, a little bit further than what we are doing, then you'll be able to kind of appreciate it, because now you know that you're well grounded, right? So that when the storms comes, you don't find yourself wanting. So let's take note of that. Now, at this point, let's got some few examples. So let me give you this example. Let's see how best we can solve this problem. So if I ask you to find, let me give you this problem. Let's think this will be a bit simple. So let's look at some example. So example one. So suppose y is equal to u to the power 2 plus u to the power 2 plus u, and that of my u is equal to x squared plus x. Now the question is, how do you find your y with respect to x? How do you find changing y with respect to changing x? How do you do that? Now, our first function was y equal to u squared plus u. Now, what is your u? So over here, let's take our time and look at something here. I want us to build on something here. So when we look at this function, the first function is y equal to u squared plus u. So it's as if that y is a function of u. Do you see that? So over here, it's as if y is a function of u. It's almost as if, so this can be written as, so it's almost as if y of is equal to, so over here we say that y is a function of u. And because y is a function of u. Now, before I touch on something else, so let me also explain this one. We also see that our u is also a function of x. Our u is a function of x, which means we can also write it as this, right? But we are going to do something really interesting here. I'm going to expose you to something that is very interesting that would make you not to forget about the chain rule. Now, remember that it appears y is the main function, because y is a function of u, and now we have another function which is u, which is a function which is a function of x. So it means that we can have a tree, something like a tree, right? It's like having a parent that has, like that has the children. The children also have the children also have their own, children. So that's the way we can look at it. So y, we said that it's a function of what? Of u. But we also saw that u is also a function of x. So now when you look at the question says that we should find the change in y with respect to the change in x. So look at what we can do. So you see that it's almost as if we want to move from y. It's almost as if we want to move from y to x. But remember, before we move from y to x, there are a lot of branches that we have to meet in order for us to do so. Do you see that? So first, we have to move from y to u. And by moving, so we have to first move from y to u. So by moving from y to u, we're going to have what we call the y with respect to u. Okay. So by moving from y to u, we are saying that what to be the change in y with respect to the change in u. And for us to move from to x, for us to move from u to x, we are saying that what happens to the change in u with respect to change in x. Okay. But remember, the whole point is I want to find the change in y with respect to the change in x. That's it. That is what we are trying to do. And this is very interesting, because sometimes if you don't know how to build such foundations, when some certain problems are being given to you, you'll find yourself wanting. So I want us to take our time to embrace such concept. Now, let's look at something here. Now we have the y or the with respect to in terms of u. How do you find your dy du? Our dy du then becomes, what do you think will be our dy du? So that becomes what? Our 2u, that becomes 2u plus 1, because remember we already have it here. So that's what we are solving here. So we differentiate u squared plus u. So when you differentiate u squared, you get 2u. When you differentiate u, get 1, right? What about when you differentiate u with respect to, you're going to have what? 2x or plus 1. Now, look at here. Now, how do you find our dy dx will just be what? So from here, it is easy that for us to move from our diagram, okay, from our diagram, for us to move from y to x, it's just what? Changing y with respect to changing x. Now, to do that, we just have to multiply these two, okay? For us to do so, we just have to multiply, okay? So we multiply these two results, and that gives us what? By multiplication, we're going to have, is that okay? So we're going to multiply these two. Now, the question is, what is our dy du? What's our dy du was 2 plus 1, and our du dx was 2x plus 1. So now Remember, because we are finding change in y with respect to change in x, it means that all your result has to be in terms of x, right? Now, already we know our u. What's our u from the question? Our u was given as what? X squared plus x. So we have x squared plus x, okay, plus 1. Then we multiply it by this. We are just only, replacing the u by its respective function given in the problem. So this is how we solve this problem. I hope everybody is getting this. It's getting interesting, right? So let's solve one more example on this, and I know you would like it. So if I give you, let me give another interesting function. If I ask you, so suppose y equal to u squared minus 3u, and u is equal to 5t minus 1. How do we find our dy dt? How do you find our dy dt? How do we do that? How do we find that? You're going to kind of do our drawing just to have a fair idea of what we are doing. Over here, the first example, the first function, y is equal to u squared plus u squared minus 3u, which means that y is a function of u. And we also have u equal to 5t minus 1, which means that u is a function of t. So it means that our y would now going to be the parent, okay? They're going to bring the t. Remember, y is a function of u, so you're going to have u, and u is a function of what? Of t. Do you see how we are burden on the problem? So it's a problem then, but we are taking our time to see how best we can, break down the problem so that we can find a solution to that. Okay, we say that y is a function of u and then u is a function of t. So in that, which means that y becomes like the parent, okay, and then the u become like one of the children or the main child or the firstborn, but the firstborn has a child, which is t, okay? Now, for us to, move from, now the question is, or the problem we're going to find or we're going to solve is that change in y with respect to change in t. So for us to move from y all the way from y to this t, it just means that there are certain things we have to follow. So first, we have to move from y to u, because there has to be a change. What has happened to the mom with respect to a change in the daughter, firstborn? What happens to the change in the mother with respect to the change in the firstborn? Okay. And then what happens to the firstborn as she gives birth? So the firstborn, the change in the firstborn with respect to the change in her firstborn. Okay. Is that okay? So this is something for us to kind of relate it to the problem we are trying to do so that you can, easily understand it. So now, as I mentioned, so for us to kind of do that, it just means that at this point, what we do is that you're just going to multiply these two results. So for us to find our dy or our dy dt, you're going to have what? Our dy du dt. I hope we are okay. In which case, we will have to find. Now the question is, what's our dy with respect to u? Our y was given us, what do you find, what to be the derivative of that? And that gives us what? 2u minus what? 3. And what about our du dt? Our du dt will be what? Remember, our u is 5t minus 1. So its derivative becomes what? 5. Good. All right. So this implies that our change in y with respect to change in t would just be what? Now we know the result for the other derivative. So that becomes what? 2u minus 3. And that we have what? Multiplied by 5. Now, remember, everything has to be with respect to t, because everything has to be in terms of t, because we are finding y with respect to change in t. Okay, good. Now, what's our u per the given problem? Our u was given us what? 5t minus 1, or multiplying 5. So this becomes the result or the solution to the given problem. I hope we are okay. So if you have any question, please again put in the comment section, and I will kind of attend to you. Now, why do we say it's a chain? Now, looking at the diagram, we see that it's a chain because you see why we said it's a function of u, and u is a function of what? T. Do you see that? So we are building like a chain. It's like you have a mother that has given birth to a firstborn. The firstborn has given birth to also has a firstborn. So now the question is, how do I trace the firstborn of the first daughter? How do I trace the firstborn of to the firstborn of the parent. How do I do that? It's by this trait that you can do so. It's like a lineage. How do I know that Amma is linked to grandmom? How do I know that Jesus is related to David? Do you see that? You see that Jesus is coming from the David kind of line. It's the same thing here. It's the same thing, same principle that sort of relates over here. All right. So at this point, I also want us to kind of look at another very important theorem, and that is the extended power rule. In previous content, we talked about the power rule. Let me give you a quick recap before we touch on its extension. Okay, so let me give you a quick recap. We said that if k is any constant, that's what we said the last time. If k is any constant, and if I have such a problem and I want to find change in y with respect to change in x, we said that so k is dropped, then we subtract 1 from the power. Okay, so we said that drop the k and decrease the power by 1. So that's what we did for the power rule. Okay, but at this point, I want us to extend it a bit. If you extend this theorem, what happens? Okay, now suppose that g of x is a differentiable function of x. Okay, suppose that g of x is a differentiable function of x. Then for any real number k, then the derivative of such a function will be what do you think the result will be? So we're still going to drop k. Good. Somebody said let's drop k. Then we maintain the g of x. Then what happened to the power? We subtract 1 from that. But then there's something we need to do over here. Then what? We multiply it by the derivative of the function. Okay, so what we do is we multiply the derivative of the main function. So anytime I give you a function to differentiate, that is what we do over here. So I can, all right, so we have something as this. Okay, this is very, very important. So I want us to take note. So if I give you such a function, let's say if I ask you to differentiate, suppose my f of x is given as 1 plus let's say cube to the power, and I ask you to find f prime of x. What do we get? If I ask you to find this, what do we get? So we apply the same rule. That should give us what? We said that what? Drop the power, right? So we drop the power, right? Then we maintain the function. Then we said that what? Decrease the power by 1. So we decrease the power by 1. So let's take our time to do it. So we decrease the power by 1. Then what happens is that we do what? We differentiate x plus x to the power 3. Okay. So first, what happens is we decrease the power by 1, then we differentiate what is under the power, right? So we differentiate what the expression that is under the power. Is that okay? Good. So we will get something as this. And when you differentiate this, we get what? 3x to the power 2. And over here, we can simplify it further. And that should give us what? 3x 2 all divided by 2 root of what? 1 plus x to the power 3, right? Remember that if I have x to the power minus half, this is the same as what? 1 over what? X to the power half. And x to the power half is the same as what? Root of x. So that is exactly what we applied over here. So take note of that. I hope we are all getting it. Let's solve one more example. So we are solving one more example on this. It's an interesting example. I think that you would love it also. So we have f of x equal to 3x minus 5 to the power 4, or multiplying 7 minus x to the power 10. How do you do that? So over here, we have combined the product rule and then the extended power rule. Is that okay? So remember if you have the product of two functions, when you find a derivative, you have to take time to do that. So let's find a derivative. So first we can cover the first function. So we are covering the first functions, and then we differentiate the second function. Then since we are talking about product, we use addition. Then we cover the second function, then differentiate the first function. So what do we get? So that should, when we simplify, that should give us, when we solve and simplify, that we should get what? So we maintain this and differentiate that, and that should give us what? 10. When we differentiate x, 7 minus x all to the power 10, that's because we drop the 10, then we maintain what's under the power, we subtract 1 from 10, then we differentiate what's inside. When we differentiate 7, that gives us 0. When we differentiate negative x, that gives us negative 1. Okay, then plus, so when we differentiate 3x minus 5 to the power 4. What you said it was that drop the power, subtract 1 from the power, then you differentiate what is under the power, and that gives 3, right? Good. Now, when you expand and simplify, you should be able to get something as this. Okay, all right. So you should be able to get something as nice as this. So at this point, I think we've been able to cover some very interesting stuff that I believe it will help in a great deal. And if I let me give you this as a takeaway. So takeaway example, if I give you this function, which is to this quotient problem. So this one, if I ask you to find, find f prime of x. So I need a result in the comment section. You can try it and put the result in the comment section and I'll attend to you. So today we've been able to cover the chain rule. We've been able to look at how best we can also extend the power rule that we learned some time back. And we've been able to tackle on some key and very challenging problems. And I've been able to kind of relate to the problem we are solving to real world situations. And I believe you will not be able to forget this concept. So please, if you find this content useful, please subscribe, like it, comment, and share it with your loved ones. And let's keep the word spreading. Thank you so much for your time.